Hi everyone! Today we are starting a new session with GEDO NovaTrack, and goal for today is take a look in automatic smoothing. So in today's lesson we will disobey any rules about the design, and we will look for the optimal line for our measured points, and this is has no relations with any regulations. It's just to get optimal line which is smooth and the offsets are more or less within set regions. So it's not always a luck to get things going smoothly, but if the track is not completely destroyed and data is sufficiently good quality, then we can expect that offsets will be fluctuating within set range. So any irregularities, any strong deviations that might raise the question if there is some serious problems either about the track or there are some influence from the measurements itself. So first thing first, what we do, where we start, and we select our measurement data, open, and look for the GDT file format. We have one specific example for today's lesson. This is sample track 1, which is included also with the installation package. So this is the same file, the same data. We click open, and then this is important to remember that we will use REHAB. So this is the only way to go into the smoothing mode and to get the solution done. We select REHAB, we select configuration, and here is the main window where we set the settings which influence how the line is calculated, how it is smoothened. So for minimum straight line length in the smoothing mode, I would recommend to select 1 or 2 meters, something like this. And for maximum error tolerance, I would recommend to set somewhere about 2 to 5 centimeters. So I set 5. Actually what it does, the higher value for the error tolerance, that would mean that the processing algorithm will be less sensitive to the change in the track geometry. It will be less sensitive to the change of the radius, transition from one element to another. So it's important to know the higher you have in the maximum error tolerance, the more rough geometry you will get. It's of course opposite. The less number you have, it means that one circular curve can be subdivided into many multiple curves because the radius is not stable enough. Okay, so I set for this track I set 5 centimeters. And the last parameter is about the transition curves. If you remember from the previous lessons, we talked about inserting the transition curves before and after the arcs or circular curves. And this is just a wild guess because we don't know the track, or we can guess, and sometimes we can for the smoothing mode we can get even better solution without using any transition curves. But it's again, if we slightly would like to respect regulations and design rules, then maybe we should know, okay, what is the radius below which the transition curves has to be inserted. But for this lesson we can keep with 500 meters, and all the circular curves below will have the transition curves before and after. If you think it's not necessary to deal with transition curves, simply disconnect just turn it off, this setting, and then you will not have any transition curves at all. Okay, we click OK, we click Analyze, and some patience for the processing, depends on the track length. And here we are. So with our settings, if we can zoom in now into the very beginning of this track, you see we have fluctuation, the unstable radius, which is 10,000, close to 8,000 meters, and then it goes back to 10,000. So this is how the smoothing is working, because the software tries to fit as much elements as possible, and as smaller you have tolerance value, the more you should expect much more elements rather than few. So and it's the same at the very end, but there is no union in the radius whatsoever, because we see here 10,000, 8,000, and then it goes down to 6,000, and then back 7,000 and 8,000. So there is no a singular value which fits for all of this. Okay, we can put it, can switch then to the design to optimization and try to put maybe a single radius instead of having all those 6 radiuses, but then it will affect our offset values. So this is important. What is the priority, offsets or geometry? And in this case we have priority for the offsets and smoothing. So this is the basically we have completed what we wanted to achieve. So we have a solution in the smoothing mode. If you remember also from the previous tracks, we don't have any specific functions to optimize in a similar way for vertical alignment. So this is again, it's to construct vertical alignments you have to follow previous track and the user manual, which describes how the vertical alignment gradient lines are constructed. So the next step is to, if you want to scale down to the offset values, and because I have now plus minus 20 centimeters and it looks ideal, but of course we can change a bit scale, so we will see a little better distortions. I will read the set user default values from the software settings, and okay, we are not interested in vertical alignment, so I keep it to 20 centimeters plus minus. And for horizontal horizontal position, I will adjust this number. It's already there, 5 centimeters plus minus. So I click OK, and the program says that it will recalculate speed and cant. Yeah, we accept. And here we are. So as you see, we have in between of those 2 blocks of circular curves, we have very long straight element, which of course is causing lots of fluctuations, ups and downs. So shifts are moving, but it's quite well balanced. If we look at the beginning, yes, there are some fluctuations onto both sides. Of course, we can go again to editing mode and try to slightly to change the situation. So maybe try to improve the offset values. But it's not the task for today. So today we want to get a smooth track within plus minus 5 centimeters, and this is the goal is achieved now. So the next step is to export the data to the horizontal alignment, and to do that we go to the file, save as, we click here, select the type, and we just select TDT file format, which is the horizontal alignment. And then we give a name. Test track 1, for example. And click save. Okay, I need. And click save. And this is done. So you can experiment at the end. You can try to run the same track with different settings. For example, narrowing down the tolerance. You can also slightly increase the length of minimum straight element, which also will have influence on how many elements are created and how it is perfectly following the measured points. Also, sometimes there is influence from the transition curve, so it's sometimes I would say it's good to know at least what radius you're expecting, what radius were during the measurements. Roughly you can have this information already from the field, so knowing that you also can set this value to more reasonable instead of just guessing. Okay, so thank you very much for your attention, and that's for today.